Yes, good evening. Yes, very good evening. Now let us solve this homework question. Yes, many people gave the answer. That is 2.5 cycles. Right. See, a CRO screen. A CRO screen has 10 divisions on horizontal scale. If a voltage signal of so and so is given, is examined with a time-based setting of 5 millisecond per division, then number of cycles of signal displayed on the screen will be. So how many cycles? This type of model already we have done. What is the setting here? 5 millisecond per division. 5 millisecond per division. And horizontally, how many divisions are there? 10 divisions are there. Okay. And voltage signal V of t is equal to Vm, nothing but which one given? 5 sine 314t plus 45. Okay. Now very simple. Sir, what is the omega 314? Omega is 314. Therefore, F is equal to how much? 50 hertz. I hope everyone knows this. And what is the time period of this one? 1 by F. 1 by 50. That is 20 millisecond. 20 millisecond. Time period of the given waveform is 20 millisecond. Okay. Now I'm taking screen. What is the screen capacity horizontally? 10 divisions. So therefore, 10 divisions into what is the operated voltage time setting? 5 millisecond per division. So what is the value? 50 millisecond. Now tell me here, screen capacity is 50 millisecond, right? And waveform time period is 20 millisecond. Therefore, this is for how many cycles? One cycle. Okay. Now tell me, one cycle occupies 20 milli. How much space is there? 50 millisecond time space is there. So therefore, what is it here? 2.5 cycles. .5 is the answer. Got it? Yes, many people gave the answer correct. Clear? Next question. Right. Match the following. Very simple. First one. First one. It is similar to like this. Or you can draw here also directly. How many? 1 and 2. Here 1. So therefore here F x is given, horizontal plate is given. So FV by Fx I'm taking. So therefore horizontal 2, right? Horizontal 1, vertical 2. So therefore FV is equal to 2 times of F. 1 second. Right? 1 by 2 times of 100 hertz. So therefore, what is the answer? 50 hertz. So among these two, P and Q, which is correct? B is correct for first one. Otherwise, you can match out of all these things like this. Okay. Now, second one. What is that? If you draw like this, one horizontal, two horizontal, three horizontal. Vertically, one vertical, two vertical. So therefore, B FV by FH is equal to, what is that? Horizontal 3, vertical 2. So therefore, FV is equal to 3 by 2 into horizontal frequency is given as 100. What is the value? 150 hertz. Right? So this is here. Okay. And C, FV by FH. So on the C, if I draw like this, horizontal 1, horizontal 2, horizontal 3. If I draw like this, horizontal 1. So therefore, what is the value now? Horizontal 3, vertical 1. So therefore, FV is equal to 3 times of 100. Therefore, 300 hertz. Got it? PSU, correct. Right. Gokul Shyam. For B, one full, two half. Where is one full, two half? It is completed path. It is complete path. Yesterday I told you this type of shape, completed path. There is no half. There is no half. It is full only. Each and every point is full only. Clear? Right. So this is the total discussion regarding homework questions. Now, let us solve few more questions. Come on. A Lissajous pattern on an oscilloscope has 5 horizontal tangencies, 2 vertical tangencies. Without giving the figure, they have given the values. The frequency of the horizontal input. The frequency of the horizontal input is 1000 hertz. What is the frequency of the vertical input? Right? What is the value? Vertical frequency is asking, so I'm taking FV by FH is equal to horizontal, how many? 5, vertical 2. So therefore, FV is equal to 5 by 2 into FH 1000. We'll be getting 2500 hertz. Right? Next, one more question. Give me the answer. Option D, option B. Who is that option B? Mahesh, did you get anywhere parabola so far? Right, simply the first line itself is playing the role. Two in phase. If you understand that, total discussion is not required. What is that? Two in phase. In phase means 0 degrees, no phase shift. Circle, ellipse, parabola, no. So directly answer is this. Okay, option B is for previous question. Okay, right. Clear? Right, let me take one more question. Answer this. Option D, option C. Right, people are giving C and D. Two input, concentrate here. What is the given data? Two inputs of a CRO are fed with two stationary periodic signals. What do you mean by stationary? It is confusing word. With this entire word, don't get confused. In your CRO, did you observe anytime the waveform is continuously flowing like this? Sine wave is there, but it is continuously flowing. As it is continuously flowing, as the operator, we cannot observe this waveform clearly. If you are unable to observe that waveform clearly, we cannot identify which box it is covering, etc. That's why one knob will be there. If you're rotating that, yes, that entire waveform is stable on the screen. Therefore, it is stationary signal. Don't think like stationary means DC. No, stationary is different. DC means constant. Steady state is different. Therefore, the waveform is not flowing like this. The waveform is appeared properly. Right? In XY mode, what is XY mode? That is non-sweep mode. The screen shows a figure which changes from ellipse to circle and back to ellipse. Means ellipse to circle, circle to ellipse, ellipse to circle, circle to ellipse, right? With the major axis changing orientation slowly and repeatedly. This is possible when? This is possible when? With the change in phase shift or with the change in frequency, means change in phase shift. 30, 40, 50, 60, 80, 90. Again 80, 70, 60, 50, 40, like that. Keep on getting changed. Okay. Now, the signals are not sinusoidal. No way. Circle is possible with sinusoidal signals only. Wrong. The amplitudes of the signals are very close but not equal. All I told in the earlier class, and few students are also asked, sir, what is the magnitude? Means will be same definitely. So wrong. The signals are sinusoidal with their frequencies very close but not equal. No way. Our topic is generally constant frequency only. Yes or no? The ellipse to circle, circle to ellipse is possible with constant frequency. If the frequencies change, different patterns are possible, but ellipse, circle, straight line, etc. is constant frequency. Therefore, wrong. Last one. There is a constant but small phase difference between the signals. Actually, here there is a constant frequency. There is a constant frequency, but small phase difference between the signals. Yes, the last one is correct. Actually, frequency word was there. Actually, it is missed. There is a constant frequency, but small phase difference between this. Yes, definitely. As the phase difference is getting changed, yes, that will be keep on getting changed. Clear? Right. Next one. Very, very simple. Come on. Shruti, right. That only I told you. That only I told you. Right. Simple. Here, a voltage signal V of t equal to A plus B sin t means constant value and sinusoidal value both are given. Fed to an oscilloscope with the coupling mode set to DC. Coupling mode. First of all, you need to understand that coupling means addition or replacing. Coupling means addition. Actually, CRO basically AC device plus DC is also coupled means now the CRO is operated in AC plus DC combination. AC plus DC combination. And other settings are being appropriate. Other settings are being appropriate. There is no change. Only the thing is, it is normally operating with AC mode. DC is being coupled. Now the CRO is operated with DC and AC combination. That's what the actual point. Then the displayed wave can be expressed as, see, last option. It is given as magnitude. Does it show the magnitude always directly? No. C option, only A. C option is only A. What do you mean by that? Only A means only DC mode. No. Second option is only sinusoidal AC mode. No. But this is coupling AC coupled with DC. Means what is that? Both. So automatically answer is A option. Right? AC DC combination mode. Therefore, automatically first option is the answer. Right? Soundarya and Aishwarya, correct? Clear, guys? Right. Next, let us take one more question. Bhavana, D option is wrong. D option is not correct. See, kindly concentrate. Right. Nowadays, you take the question as without coupling, you give the answer later. Okay. Whatever the given question that you answer first. Coupling means addition. Coupling means addition. Can you try to understand English meaning? Coupling is addition. AC is there. DC is coupled. So AC plus DC operation. But in the last option, it is given as magnitude. Does it give the waveform or does it give the magnitude? Means it will give the waveform, not the magnitude. Magnitude we will measure by counting the divisions. That is the reason why last option is not correct. Only first option. Clear? Right. Now, this one. Kindly don't write anything. I will answer this. See, this is the CRO screen. This is the CRO screen. Right? And this is the center axis. Clear? Right. Concentrate here. This is Vx, right? And this is Vy. Okay. Now the point here is concentrate. No one should write anything. If you understand this, it will be the revision of yesterday's topic. And with this question, you can answer any waveform given on X plate, any waveform given on Y plate blindly. So kindly concentrate. Don't write anything. Right. See, concentrate. First of all, sinusoidal signal of frequency 2 kilohertz is applied to the X deflection plates. 2 kilohertz. So what is the frequency? 2 kilohertz. What is the time period? 0.5 millisecond. Okay. And sawtooth waveform of plate, sawtooth waveform is given to vertical with 1 kilohertz. So therefore, I'm taking that sawtooth waveform. I'm taking sawtooth waveform. So what is its frequency? This frequency is 1 kilohertz he has given. 1 kilohertz means time period is how much? 1 millisecond. Time period is 1 millisecond. Sir, here also, what is the time period? What is the time period? 1 millisecond time period I'm taking here. But concentrate, concentrate. This is the 1 millisecond of time period, for example. Okay, here 1 millisecond and here also 1 milli. That only we can combine. I told you already, frequency must be, what is that? 0, 90, 180 means should be same. But this horizontal plate waveform is having 2 kilohertz. 2 kilohertz means what is the time period? 0.5. So therefore, in 0.5 milliseconds of time, one sine wave and other 0.5 milliseconds of time, other sine wave, nothing but 2 cycles will be present. 2 cycles will be present. Clear? Right? Means in 1 millisecond of time, here 1 cycle, here 2 cycles. No problem. No problem. It is given. Right, sir. What is this time? 0. This time is 0.25. This time is 0.5. This is 0.75. Of course, milli. And this is 1 milli. Okay. Here also 0.5 milli, 0.75 milli, 0.25 milli, 1 milli, like this. Okay, very simple, just like yesterday's point. Sir, at 0, extend this. At 0, extend this. At 0, extend this. This is what the point. Okay, and for more clarity point of view, I'm giving each and every box also. Clear? Right. Concentrate here. Sir, at 0.25, this is there. At 0.25, this is there. Therefore, it is coming here. Right? At 0.5, right? It is keep on going. And at 0.5, up to this. What is this? Here. Clear? Next, after that. At 0.75, at 0.75, it is keep on going at 0.75. Here. Right? After that. At 1, and here at 1 millisecond, this is what the point. But by this time, can we say it is a vertical straight line? No, this is 0, 0.25, 0.5, 0.75, one time only. But sir, if I take half of this, 0.125 time, this is what the value. Extend this. 0.125 means half of this one. 0.125. If you are extending this, right, it will be coming to this point. Okay, now, sir, at 0.375, at 0.375, this is the value again, you extend it. If you're extending this 0.375, half of this, right, it will be coming to this point. Now with this, we can understand simply, sir, what is the plot? Concentrate here. like this. And again, one more cycle also will be like this. Okay, now check it here. First option. Clear? This is what the procedure, but blind shortcut we can write without taking this entire thing also we can write. So how many cycles of sine wave is there? 2 cycles. Combined with which one? Sawtooth. So resultant waveform will be sine wave. So therefore this is wrong. Okay. So sine wave is given on X plate. Sorry. X plate or Y plate? X plate means horizontal is not possible. Only vertical. First option. Without wasting the time, directly you can write the answer. Clear? Any confusion in this? With this, you can understand that whatever may be the waveform on X plate or Y plate, blindly, you can take the same procedure 0 to 0, 30 to 30, 60 to 60, like that. You combine and you'll get the corresponding plot. Clear, guys? Right? So this is the total discussion regarding entire CRO chapter in terms of measurement point of view. What is it? Sweep mode, non-sweep mode, etc. Okay, right. Now, the next topic in the CRO is CRO probes. CRO probes. Sir, what is CRO probe? Nothing but from function generator to CRO or CRO to the corresponding breadboard or circuit, one special wire is there. That is called as CRO probe. That is called as CRO probe. Vishnu Ajit, correct. That only. Right now, CRO probe, nothing but which one? Yeah, whatever the wire we are connecting from function generator to CRO or with the CRO, whatever the wire is connected is called as CRO probe. That's why in your laboratory, while you are operating the CRO or while you're doing the CRO experiment, whatever the cables or whatever the wires you used in the machine's laboratory, generally not acceptable in the CRO experiment. A special probe will be there. A special probe will be there. One large sharp knife type of pointer will be there. Those type of wires will be there. Those are called as, what is it? CRO probe. CRO probe. Clear? Right. Kundrapu Murali, connect any text circuit. Very nice. Right? CRO probe means it is connecting the corresponding circuit. Okay. Whatever the CRO probe is there, if you want to write that CRO probe in circuit diagram, if you want to represent in terms of circuit diagram, what can be the representation? That's what the point. Listen carefully. This is VS. This is VS. Here, ground path will be there. VS. Okay. And CRO cable can be represented as nothing but CRO has impedance. Yes or no? That impedance is equivalent of, what is a parallel equivalent of R and C. This is probe. P means probe resistance and probe capacitance. Okay, CRO probe has the equivalent circuit of which one? R and C parallel. After that, this CRO probe is connected to CRO. Connected to CRO. This is from function generator and this is to CRO. Sir, to the CRO side, input voltage will be there definitely. Therefore, that input voltage is VI, nothing but input voltage at CRO. Sir, CRO has also some impedance, right? So therefore, CRO input resistance and CRO input capacitance. CRO input capacitance RI and CI, right? These two are also parallel. This is the equivalent circuit of CRO probe. By this concept only, all the theories are built up. What is it? Probe impedance is RC parallel. CRO impedance is also RC parallel. But CRO probe has some capacitance. Nothing but CRO probe. What is it? Cable will be there. That cable has some insulation. That insulation has some corresponding capacitance. So therefore, that is called as cable capacitance. What is CC? This is cable capacitance. Cable capacitance generally negligible in the practical conditions. If it is given in the question, substitute. Otherwise, simply it is neglected. This is cable capacitance. Every CRO probe or every wire is having some cable. So therefore, that cable is having some capacitance. Clear? Right. Clear? So this is the total equivalent circuit. Now I'm modifying this. Anyway, this is neglected. This is neglected. So therefore, can we draw like this? Can we draw like this? This is Vs. Okay. And this is R and this is C. And this is also R and this is also C. Right? Now, here, this is RP, this is CP, this is RI, this is CI. Both are same or different? Concentrate. This and that both are same or different? Same only, because these two parallel, both are coming in series. Now tell me, what is the total voltage for this entire cable? Vs is the total voltage. Vs is the total voltage. So therefore, yes, Vs is the total voltage. Where is Vi? Voltage across R and C combination. So therefore, here Vi will be there. Here Vi will be there. This is the modified structure. Nothing but in order to have the easy idea, we are taking here. Clear? Right now. So therefore, concentrate here. Sir, what will be the equivalent circuit behavior? What will be the equivalent circuit behavior? Kindly concentrate. Sir, we may be operating the entire CRO with high frequency or low frequency. We can take. Therefore, total explanation I'm dividing into two categories. One is lower frequencies, and here higher frequencies, lower frequencies and higher frequencies. Okay, sir, what is that? If this resistance anyway independent of frequency, but capacitances are there which depend on frequency. So therefore, sir, XC is equal to 1 by 2 pi FC. Here also, XC is equal to 1 by 2 pi FC. Okay, sir, what is that? Frequency is low. If the frequency is low, XC is high. If the frequency is high, XC is low. Okay, right. Now tell me, sir, here, if XC is more, opposition will be more. If the opposition is more, signal will be passed or signal will not be passed, means opposition more means signal will not pass through this properly. That's why be clear. Under low frequency condition, XC more, nothing but more opposition. Then the entire signal passes through. The entire signal passes through resistance only. That's why this is called as which loading? Resistive loading. Clear, guys? This is called as resistive loading. I'm coming again. Sir, XC is more. People are getting confused like, sir, XC is dominating, capacitance is dominating, capacitor load should be there. No. XC is dominating means opposition is more. If the opposition is more, automatically the corresponding the signal will be passing through the corresponding resistance only. Clear? Right? So therefore, for a given cable, capacitance is constant. For a designed cable, capacitance is constant. The frequency is variable. According to our requirement, we are going to keep the frequency. So therefore, yes, I am operating for 50 hertz, 100 hertz, 1000, like that very, very small value. Then it is acting as resistive loading. Here, if XC is very low, as I'm going for 10K, 20K, 30K, 40K, etc., very, very high frequency, 100K, 1 mega, etc., then XC will be low. Therefore, the more signal will be passing through this. Assumption is what? This opposition is comparatively more than this, or we can say this opposition is comparatively less than the resistance opposition. Therefore, this is called as capacitive loading. This is called as capacitive loading. Right now, under this condition, what is the voltage division law? What is VI? What is VI? Total voltage into, here also VI, total voltage into. Sir, both resistors are coming in series. If both resistors are coming in series, voltage division law. What is it? Ri by Ri plus Rp. Ri by Ri plus Rp. Okay. And here, what is it? Both capacitors are coming in series. Voltage division law. If you are finding voltage across Ci, means you should multiply with Cp by Cp plus Ci. Cp by Cp plus Ci. Clear? Now, this portion is called as K. This portion is called as K. This K is nothing but attenuation factor. Attenuation factor. Right? In the electrical language, voltage drop we say, but in the electronic language, attenuation we say, voltage attenuation. Yes. Clear? Right. Now tell me, these are the formulae, okay. But my question is, sir, whatever the frequency we are using, the attenuation should be constant or variable. I'm using low frequency or I'm using high frequency, the attenuation should be same. Sir, why? If the frequency is changed, time period must be changed, but the magnitude should not get changed. Suppose I'm giving, concentrate here. I'm giving, suppose X volt, for example. Here I'm expecting at least X minus volt, but that should be fixed or keep on getting varied? Fixed. Therefore, the drop in this must be constant always. Then only we can say. Otherwise, if the frequency is changing, if the drop is keep on getting changed, the input voltage is keep on getting changed, the two more voltage drop here less voltage will be applied to CRO. That is the reason why what we can say, whatever the frequency we are giving, the attenuation must be same, but which must be changed? Frequency changing means time period must be changed, but magnitude or amplitude of the input voltage should be almost constant. So therefore, what we can say now here, for same attenuation, at all frequencies, for same attenuation at all frequencies, right? If this heading is clear, I can proceed with simple mathematics. First of all, is this heading clear, guys? Respond. Now everyone should respond. Why am I taking this blindly or by technical principle? Right, simple logic. See, whatever the frequency you are giving, suppose I'm increasing the frequency, time period must be changed, time period must be reduced. If I reduce the frequency, time period must be increased, but I'm not changing the voltage magnitude. Therefore, I will expect the same voltage magnitude every time with the corresponding drop of X volt or small voltage. That's why as the frequency is getting, kindly constant, I'm repeating, as the frequency is getting changed, what is it here? Attenuation means the voltage drop should be same. Which must be changed? Time period, which is displayed waveform will then no, time period should change. Yes, that is okay. But voltage magnitude should be same. For that purpose, what should be the condition? What should be the condition? What should be the condition here? Concentrate here. Sir, here. For same attenuation at all the frequencies. Again, people are asking that, sir, why do you want same voltage drop? Come on here, minimum common sense we can say 100 volt is applied. Here you expect 99 volt, for example. For example, if I'm changing the frequency, what you are changing? Frequency. Frequency means which should change? Time period should change. Suppose along with the frequency, magnitude is also changed. Are you operating the CRO properly here? No, more and more voltage drop will be there in the CRO probe. Is it acceptable here? No, that's why our task is what? Frequency task. You're missing small thing. Frequency task. Frequency task means time period only depending, but not the voltage magnitude. That is the reason why what we can say, yes, if the frequency change, the frequency related term, the time period should be varied. Frequency is varied, time period should be varied. Therefore, whatever the magnitude I'm giving, that magnitude should appear as it is. Otherwise, I'm applying 100, but which is appeared across here, we don't know. Is it possible here? No, that is the reason why we need to have same attenuation. So what is the same attenuation? In the resistive load means low frequency, Ri by Ri plus Rp, and high frequency, Cp by Cp plus Ci. These two should be equal. If these two are equal, automatically we can say that if these two are equal, automatically we can say that yes, same attenuation will be there. In that way, we need to design the CRO probe. In that way, we need to design the CRO probe. Yes, Shiva, I'm coming for that only. As the frequency is changed, the voltage drop will be changed, Xc is changed, but how to maintain the constant, how to maintain that as constant, I'm taking that. That's what I'm saying. For same attenuation, for same attenuation means for bringing the same voltage drop, what should be the condition? That's what I'm saying. So therefore, I'm equating these two. I'm equating these two. First of all, try to understand the English statement. Our requirement is to maintain the same drop. In order to maintain the same drop, the manufacturer should design the CRO probe with dash condition that we are going to take it now. What is that? These two should be same. Therefore, RICP plus RICI is equal to RICP plus RPCP. Here RICP cancel. What is the answer? RICI should be equal to RPCP. If this condition is satisfied, concentrate, if this condition is satisfied, then we can say you operate for low or high frequency, no need to worry, voltage drop will be same. That is, attenuation is same, but according to the frequency, the corresponding time period will be changing. The corresponding time period will be changing. Right? Urukonda Sandesh, not indirectly, directly only we are making. Yes, we are making voltage drop as a same. That only I told you. Whatever the frequency we give, what is it? Time period should change, magnitude should not change, but actually magnitude will get changed. That's why in order to maintain that as constant, yes, condition. That's why what is the first condition to the manufacturer? With the manufacturer is they will check RICA means input resistance and input capacitance product. Okay, and should be equal to probe resistance and probe capacitance product. If this product is satisfied, but if this condition is satisfied, automatically we can say the CRO probe is working properly. As the frequency is changed, time period will be changing, magnitude is not getting changed. Happy, we can proceed over with normal magnitude. Clear, guys? I did not say, before this topic, I did not say the voltage drop attenuation will be same. I did not say attenuation should be same. I did not say attenuation will be same. I said attenuation should be same. So in order to get attenuation same, what we have to do means this we have to do as the manufacturer. That is what the point. Clear? Right now, so this is the total condition related to the CRO probe. But CRO probes are different types. Generally, we say 10 to 1 probe, 10 to 1 probe, or 10:1 probe, 10 to 1 probe, or 10:1 probe. What is the meaning of this? Very simple. 10 to 1 probe or 10:1 probe means, right? That is K is equal to 1 by 10. Whatever the attenuation factor is there, no, that is 1 by 10. If they want to design the attenuation factor as 1 by 10, right, what should be the condition? Very simple. So what is the K value? K is equal to, for low frequency, I'm taking as Ri by Ri plus Rp. This is equal to how much? 1 by 10, because 10 to 1, yeah, 10:1 means K equal to 1 by 10. What should be the condition? Sir, 10 Ri is equal to Ri plus Rp. Therefore, Rp should be equal to 9 times of Ri. If this is satisfied, we can design, with this condition, we can design the 10:1 probe. Now, in the same way, K equal to, what is it? Cp by Cp plus Ci is equal to 1 by 10. Okay. Now, 10 Cp is equal to Cp plus Ci. Here, what will be there now? Cp is equal to 1 by 9 times of Ci. If this is satisfied, we can say, yes, the K is 1 by 10. We can design the attenuation factor of correspondingly 10. 1 by 10, we can say. Right. Sir, Vishnu Ajit, for f equal to 0, there is no operation at all. F equal to 0, there is no operation at all. The CRO itself indicates some frequency. If you give the frequency, then only we can say corresponding value is there. Right? Is it 1 by 9 Ci or 9 Ci? 1 by 9 only. Again, you multiply these two. Rp into Cp is equal to 9 Ri into 1 by 9 Ci. 9 get cancel. What is that? Rp Cp is equal to Ri Ci. Yes, Rp Cp should be always equal to Ri Ci. Then we can say same attenuation for all frequencies. Same attenuation for all frequencies. Right. People are saying that Cp is equal to 9 times of Ci. What is this? What is this? Check it here. Check it. Clear? Okay. Sir, if I'm taking only resist to load, sir, what is the R effective? Means R total. If R total is being taken, what is it here? Resistors are coming in series, already told you. Therefore, what is the formula? Ri plus Rp. Ri plus Rp. Sir, Rp equal to 9 times of Ri. So therefore, Ri plus 9 Ri. Therefore, R effective is equal to 10 times of Ri. In the same way, sir, what is the total C effective? Sir, capacitances are coming in series. Capacitance are coming in series. As the capacitance are coming in series, what is the formula? C1 C2 by C1 plus C2. Is that no? If you simplify this, you will be getting 1 by 10 times of Ci. So these are the conditions to be satisfied to design the 10:1 probe. To design the 10:1 probe where K is equal to what is that? 1 by 10. Clear? So this is the thing related to CRO probe. Right now, I'm giving, of course, today is the last day, but for this measurement, but I'm giving some homework. 20:1 probe. 20:1 probe. Take this as homework. Simple point. K equal to 1 by 20. That's it. You can proceed. Just for idea purpose, I'm giving. Clear? So this is the entire thing regarding CRO probe. But all these are just miscellaneous topics only, but sometimes questions may be possible. ESC, generally questions are possible. I'm taking the question so that you can understand. Get this? Option B, option A. Two answers. Again, two answers. Right, sir. the input impedance of CRO. So what is given? Ri 1 mega ohm, Ci 45 picofarad. If it used compensated 10 to 1 probe, so therefore K is equal to 1 by 10. The effective input capacitance he is asking, C effective is dash. Come on. Effective, C effective he is asking. First of all, go back here. Sir, 10 to 1 probe, 10 to 1 probe, right? What is C effective? 1 by 10 times of Ci. Direct answer. C effective is equal to 1 by 10 times of Ci. 1 by 10. Ci is how much? 45. So therefore, what is that? C effective is equal to 4.5 picofarad. Some people give the option as B. Nagaveera Babu, Dinesh, Vaibhav, Mukul Jagtap. Many people give the B option. Why? How are you getting B? Baby Kavyasri, 5 pico. You also give the B option. How B? At least my after my explanation, is it clear or not? Right. So this is the thing regarding CRO probe. Of course, this is the gate point of it's a miscellaneous topic, but chance is there sometimes. Chance is there. Right now. One more thing is vertical deflection sensitivity. Sir, why do we discuss only about vertical deflection sensitivity? Means, all I told you, whatever the input waveform is given, that will be applied directly to the vertical plates or horizontal here. First vertical plates, then what vertical amplifier directly to the vertical plates, but horizontal side trigger circuit is there, sweep generator is there, then horizontal amplifier. That's why the sweep mode operation means X plates are with sawtooth, but Y plates, vertical plates are always with corresponding given input. That's why always we concentrate more on the vertical deflection. Why? X plates are anyway reference only. Sawtooth always reference in the sweep mode. That's why vertical plate. That's why we are going to define vertical deflection sensitivity. Vertical deflection sensitivity. All these topics, today's topics are miscellaneous topics only, but sometimes chance is there. But for ESC, yes, most chance, more questions are possible equally. Here, sir, vertical deflection sensitivity. Concentrate. In order to get vertical deflection sensitivity, we need to concentrate on vertical plates and the corresponding screen. Vertical plates and the corresponding screen. Okay, Ali, you know that velocity of electron beam at the final anode, at the third anode, at the accelerated anode is root 2 QVA by M. You know that. Okay, these are called as vertical deflecting plates. Yeah, simply vertical plates. These are called as horizontal deflecting. Yeah, simply horizontal plates. Okay, what is the terminology here? The terminology is the separation between these two plates. I'm taking as S. The separation between two vertical deflecting plates I'm taking as S. The length of vertical deflecting plate is capital L, right? And the distance from vertical deflecting plates to screen, the distance from vertical deflecting plates to the screen, I'm denoting with capital D. With respect to the space between these two, with respect to the length of the plate, and with respect to the distance from here to here, based on these only, how the deflection is there, how the striking is there, how the display is there will be there. So that's why vertical deflection sensitivity means we are depending on all these parameters. Clear? Right. Now, here actually in sometimes the question will be given like, see, from the center of the vertical deflecting plate to what is that screen, that is also D. generally from center only, but normally I'm giving like this. From the center of the vertical deflecting plate to the screen, the distance is capital D. Approximately I'm giving like this. Okay, and one student asked yesterday, horizontal plates means vertical, or horizontal means simply horizontal plates, horizontal deflection plates, X plates, all are same. Vertical plates, vertical deflection plates, and Y plates. Okay, now, so terminology also I'm giving. Sir, capital L, length of the vertical deflecting plates. Capital D, distance between vertical deflecting plates and the screen. And S is separation, don't get confused, separation between vertical deflecting plates. Okay, means vertical deflecting plates are separation length. Of course, this separation will be changing for a given input. And VA, accelerating anode voltage, of course, you know, final anode voltage. Okay, right. So in order to know this vertical deflection sensitivity, first of all, I'm defining sensitivity, deflection sensitivity, because many people did not attend my measurements. It's an electrical measurement. That's why I'm giving that definition first. What is that? Sensitivity. The two, deflection sensitivity. The sensitivity, I'm writing deflection sensitivity. Very simple. Deflection sensitivity. Those who have attended my electrical measurements, this topic is revision. Other people, just normal definition. Sir, what is the sensitivity? Very simple. Yeah, sensitivity means I'm giving small change in the input corresponding to the given change in input if the output change is available. If the output change is available, then that is called as correspondingly high sensitivity, a low sensitivity we can define. Means for a given input change, corresponding output change is there, and small input change is there, then also output response is there, high sensitivity. If not, low sensitivity. Okay, right, sir. Deflection sensitivity. Deflection is the output. Why? Concentrate, sir. To these two vertical plates, we give the input supply voltage. Based on that voltage, the deflection will be there. So which is the input? Voltage is the input. Which is the output? Deflection is the output. Are you getting my point? Given input is voltage and observed output is deflection. Observed output is deflection. So therefore, what we can say here, the amount of deflection produced per unit deflecting signal voltage. Per unit deflecting signal voltage means some voltage is given, based on the deflection took place. That is what the way is known as deflection sensitivity. Is known as deflection sensitivity. Clear? Simply S is equal to, what is that? S is equal to D by VD. S is equal to D by VD. D, deflection. Voltage, deflecting voltage. Right? Deflection may be in terms of centimeter or millimeter, or divisions also they may be giving deflection in maybe centimeters or millimeters, or divisions also. Clear? Right now, sir, this yes and this yes, don't get confused. This is separation, but this is sensitivity. So don't get confused. Don't get confused. Clear? Or you can write yes, D also, deflections, so that you can understand easily. Okay. Now the formula is here, sensitivity. After that, inverse sensitivity, simply DF, deflection factor. We say it is very, very, very popular question, especially in the ESC paper for electrical people only. Find the deflection factor. Of course, for electrical people, in the electrical measurements, I told you, but other people point of I'm giving deflection factor, nothing but inverse sensitivity. What is inverse sensitivity? 1 by S. This also D only I'm taking for idea purpose. Otherwise, don't get confused with S and other S. Reciprocal of sensitivity, yes, volt per centimeter, volt per millimeter, volt per division. Okay, with all these basics, the vertical deflection sensitivity formula I'm giving SV, vertical deflection sensitivity formula SV is equal to LD by 2SVA. L, length of the vertical plates. L, length of the vertical plates. D, distance from the vertical plate to the screen. Yes, separation between those two. VA, final anode voltage. Based on that anode voltage also, it is depending. So this formula you have to remember. This formula you have to remember. This is vertical deflection sensitivity formula. All these are miscellaneous topics in CRO. Clear? Right? I actually this formula will be given directly, but what was the theory? So slowly, what is deflection sensitivity? What is inverse factor? What is the terminology? And then I'm giving the formula. Right. Today, total syllabus will be finished, including miscellaneous. Including miscellaneous, total syllabus will be finished. No need to worry. Clear? S is separation. S is separation. Separation. Here, S means separation only. Separation only. Otherwise, you can write this as SV also. This is normal formula. And this is by the plates based formula. S means separation only. Right? Now, next one more topic is this very, very simple point. Relation between rise time and bandwidth. Relation between rise time and bandwidth. This general formula. I hope few people know about this one. Kindly let me know. Harsha Guntakal. PDF will be given. Video will be there. Go back and go to the 65 slide page. Keep on typing 65, 65, 65. What are you listening? I don't understand. Right. Kindly answer. Relation between bandwidth. Yes, it's actually control system notation, but as the waveform is given, that's I'm giving. The formula here is rise time TR. Rise time TR is equal to, can anyone? 0.35 by bandwidth. But in a control system, some other formula is the rise time in terms of zeta. Subject to subject, the formula is different, but final result is same only. That is 0.35 by bandwidth. Rise time TR equal to 0.35 by bandwidth. In the ESC objective paper, formula may be the direct question. Formula may be the direct question. Or sometimes question may be given, very, very, very simple question, but confusing values. Now try this. He's asking rise time. So rise time formula is 0.35 by bandwidth. Now I gave the formula. Kindly simplify and tell me. Looks very simple, but many people are giving the wrong answer for this by the confusion of decimal point. Yes, right. First time I'm getting the correct answer from all of you. For this question, I'm talking about for this question. Okay, Sunil Wagmer, different answer. Okay, all of you are given the first option, and Vaibhav gave the D option. And Sunil also gave the D option. This is the main problem. Sir, 0.35 by bandwidth. What is the bandwidth? 10 megahertz. 10 megahertz. What is the answer? 10 megahertz. This with this only, this is not very critical, but very small decimal point based, but people are getting confused. What is that? 35 by 10, 3.5, 3.5 micro, 3.5 micro, right? People are writing like this, sir, the thing is not there, etc. They are saying, so 3.5 micro, etc. They are giving like this. But be clear, be clear, it is not 3.5. By mistake, what people are doing now, 0.35 by 10. So 101 decimal will be cancelled. Come on, yeah. Come on. This is the general mistake done by the corresponding. What is it, student? What is it? 0.35 by 10 means 0.035, 0.035. 1 by mega means micro. This is what the point. And by observing 0.035, two students gave that 0.035 nanoseconds. Come on here. Our answer is micro, not nano. Yes or no? That's why be clear with this term. Simple question. Don't get negative mark with this. Don't get negative mark with this. If the question is too critical, yes. Okay, if you are losing the mark, okay, acceptable. But here, very simple. Clear? So what is the answer here? 35 nanoseconds. That is the first answer. 35 nanoseconds. And one student is asking that, what is the meaning of first line? Nothing here, nothing. Simply direct current. It means actually the supply will be given. No, that supply with respect to the corresponding bandwidth they are giving. That's what that means. Direct current means DC current. How the frequency? Not like that. It is given with the current with the corresponding bandwidth. That's what the point. Clear? Am I? Am I audible? Just power problem. So this is the bandwidth related question. So this is the total discussion regarding entire CRO for gauge and ESC, all the topics. And in the digital altimeter, one more topic is there, that is dual slope integrated type ADC. Dual slope integrated type ADC. This is generally ESC conventional model, but sometimes they're asking one simple 1 mark question also. In the gate or ESC, that to very, very rare cases, but on the safe side, I'm giving this entire thing. So what is that? Kindly concentrate. Dual slope integrating type ADC. What is that? In the 3 or 3.5 devices or 4 or 4.5 devices, whatever the ADC we use, that ADC is which one here? Dual slope integrating type ADC. Dual slope integrating type ADC. Clear? Right. Now the question here is, concentrate. See, topics are there. One more topic is there for ESC people. Kindly concentrate here. Dual slope integrating type ADC is there. In this dual slope integrating type ADC, right? What is the construction? What is the block diagram? Actually, this is generally 32 marks here, 24 marks question in the ESC conventional. But in the objective paper, how the questions are framed on this. So you have to understand that model. I'm going to explain the total topic in detail. So kindly concentrate. Dual slope integrating type ADC. It is used in digital altimeters generally. It is used in digital altimeters. But sir, it gives or measures average value. It gives or measures average value. Sir, how can you say that it measures average value? I'm going to prove with complete block diagram explanation. Okay, in the gate also, but very rare cases for electrical people, but chance may be there, miscellaneous topic. So be clear. Sir, here, this is the block diagram of dual slope integrating type ADC. This is a block diagram. Dual slope means two slopes will be there. One is this increasing slope, other one is decreasing slope. That is dual slope integrating type ADC. So what is the structure? I will explain clearly one by one block. After that, operation will be clear. Sir, EM or EI, input voltage, which is to be measured, that is given to this EI terminal. And the switch is having one position here. Switch is having one position here. But actually speaking, we can write like this. This is the switch position. This is the switch position like this. Okay, this is one position. This is two position. Okay, if the switch is kept at one, input voltage is being connected. Input voltage is being connected. This is R and C network integrator. I hope everyone knows that integrator with RC network. So this integration symbol, integrating means whatever the signal is coming, it is keep on integrating means what? Yes, ramp line, increasing line. Okay, output of the integrator is E0. This is given to zero comparator, zero detector or comparator, we can say. This is having two inputs. One is output from the integrator and one input is always ground connected. Therefore, this is always zero. This is always zero. And output of this zero detector is given to AND gate. And one input of this gate is always connected to the oscillator. So input is available. Once the input is available through this path also, this will give output count. Therefore, based on this output, the counter counts and corresponding display will be there. Example purpose, I'm taking 4-digit dBm here. You can take 3-digit, you can take 3.5, you can take 4 or 4.5 as you wish. Example, I'm taking 4-digit. What is this? I'll tell you. What is this entire portion? I'll tell you. Clear? Now be clear, guys. Very, very small logic, but this is equally important for other people also. General topic point of view. Concentrate. Sir, input is not given. Input is not given. Switch is under open condition. No input, no integration. Therefore, what is E0 value? 0. So therefore, 0 here, 0 here. Both are zeros. Means automatically what we can say? Yes, 0 and 0 means this zero detector gives the zero output or no output. That is comparator. This will be compared with this 0, but both are same. No output. If no output is there and the gate, one input is high, one input is low. What is it here? Output is 0. So count is not started. Means instrument is not yet started. Okay. Now, sir, here input is on. Input is on means after giving the input and then input attenuator, range selector switch. After that, it is given to dual slope ADC. I told you, this entire thing is dual slope ADC, right? Okay, that input is given. So whatever the input we are giving, yes, that is applied here. This function is to always integrate. Therefore, once it is giving the output, now tell me, is it increased from 0 or not? Yes, so far 0 was there, but now some output is happening. Therefore, this is 0, this is non-zero. What is it here? 0 and non-zero comparison. It will do the comparison and correspondingly output will be given. Yes, one signal will be, high signal will be given. this high signal is applied to this. This high signal means 1 0 low, 1 high like that. Therefore, what is that? It is taking the corresponding output. Output 1 clock pulse, 2 clock pulse, 3 clock pulse, 4 like that will be there. Based on that, I told you, what will be there? Counters will be there. How many? I'm taking 4-digit means 4 decade counters. Then 47447 ICs. Then 7 segment code path, and the corresponding display will be there. So corresponding counts will be available. Okay, now tell me, this will entire thing, this entire process will be continued up to, this entire process will be continued up to here 9999. Why? I'm using 4-digit. Suppose if you use 3-digit, what is it? Only 3 nines. Suppose 3.5, 1,999. 4.5, 1,4. Like that, any device you take it, no problem. Therefore, this entire process will be continued up to, what is that? Maximum count, that is 10 power 4 count, 10,000 counts, 0, 0, 0, 0 to 4 nines. Okay, this is called as first integration phase. This is called as first integration phase. Okay, that is what I'm giving now. See, first integration phase at t equal to 0. What happens here? I'm giving total notes. At t equal to 0, the switch is thrown to position 1. Who? Operator will thrown to position 1. I told you already. Here it is moved to 1. Then what happens here? Then VM will be connected. Yes, input will be connected. VI will be connected as you wish. VM or VI, no problem. Then capacitor gets charged. Then clock pulses count started. So therefore, what is it? The capacitor gets charged. Then output will be there. Automatically, the signal will be available. The counter starts counting. But it will count one by one, one by one, one by one. Up to which one? Until its maximum count. Until its maximum count. Okay. So therefore, what is it here? Yes, until its maximum count. What is that maximum count? Check it. 0 to T1 I'm taking. What is it? At 0 it is started up to T1. Means that time period I'm taking as capital T1. What is it? Here, sir, this is 0 for example. This is T1. Okay, right? This entire time period is capital T1 I'm taking. Okay, it will reach us to maximum value. We can means integrated. Output will be reaching to its maximum value. Okay, and this will be continued up to which value? Until it counts the maximum number that I told you, 10 power n. N means number of full digits. Okay, 10 power n, number of corresponding digits. And T clock, each and every clock pulse will have its own time. So therefore, if I multiply these two, we are going to get the total time period. Up to this, clear or not? What will happen after that? I'll tell you. Up to this, clear or not? Input is given, that will be keep on getting integrated. Yes, clock pulse will be keep on getting generated. Yes, count will be counted up to maximum count. Why I'm taking T1? Sometime I'm taking, sometime T1. Okay, but that T1, 0 to T1 is capital T1 time period. That should be equal to 10 power n counts into 1 count when 1 clock pulse. Time will be there. That should be multiplied. Nothing but like this 1, 2, 3, 4, like that. 1 clock pulse, 2nd clock pulse, like that. 10 power n clock pulses will be there. And this clock has its own time. So if you are multiplying those two, you are going to get the corresponding value. This is T1. Now what happens, sir, it reaches to maximum that I'm taking as this T1 time, this one. Okay, very, very important. Sir, if one more count is coming, for example, what happens here? 9 plus 1, 10, 0. 9 plus 1, 10, 0. 9 plus 1, 10, 0. 9 plus 1. It becomes 0. But here, carry pulse will be there. No, that carry pulse, carrying element will not be there here. But other external, but some other element, flip-flop will be there. That will be triggering this one. Therefore, the carry pulse will trigger the flip-flop. Then this flip-flop output will be such that it will be driving the switch from switch 1 to switch position 1 to switch position 2. What is it? I'm coming. Once it reaches to full count, if the next count is coming, this carry pulse will give or activate the flip-flop. The flip-flop will give the output such that it will drive the switch. What is the driving the switch? From position 1 to 2. Then what will happen here? Then negative E reference, negative E reference. Why? Means dual slope. One is increasing, one is decreasing. That's why negative E reference is always common, always common. Therefore, now tell me, what is the input available here? What is the input available now? Negative value. Sir, negative value given to this integrated means the value will be reduced or increased. Come on here. Negative value is given. Integrating means whatever the maximum value is there. Now negative value is coming. Now it is keep on getting decreased. It is keep on getting decreased. Are you clear? We can say negative integration, etc. We can say negative value is given. The output will be maximum to negative value is coming. No. Therefore, what is it? Capacitor getting discharged. In that way, we can say yes, output will be keep on getting reduced. Output will be keep on getting reduced. Right? Log nor n increases you have given. Which one increases? Which one increases? Negatively increased means the value will be decreased. So therefore, E naught will be decreased. That only I gave you in the second point. See, second integration phase. What is that? The count reaches maximum count. Then overflow, that is carry pulse given to flip-flop. This flip-flop moves the switch to position 2. Then negative V reference is connected. The capacitor gets discharged. The capacitor gets discharged completely. We don't know. That depends on corresponding input. The capacitance gets discharged completely when some clock pulses, we don't know, some clock pulses, X clock pulses are produced. I'm assuming X clock, but we don't know. Why we don't know means, right, from where it is started, up to which one it is going, we don't know the magnitude. So that's why simply we can say some clock pulses will be generated. By the time it will reaches the zero value, it will reach the zero value, means completely discharged. Then what will happen here? If the capacitor is completely discharged, this will become zero. This is always zero. What is happening here? 0 and 0, same. Then 0 means low signal. Low signal means no output. The count will be stopped. The count will be stopped. That I'm writing here. Check it here, right? X clock pulse are produced. Then tell me T1 to T2, I'm taking as capital T2. Okay, X counts and X clock pulse are counts, and here simply T clock. If you're multiplying these two, T2 will be there. One is integration, one is de-integration. We can say first integration and second integration. Dual slope means positive and negative will be there. Okay, whatever the discussion I have taken, I'm drawing with you the figure. Kindly concentrate. At 0, it is increasing up to which value? Maximum. This is V naught, reaches to maximum. Then second integration phase coming like this. Second integration phase coming like this. Okay, this is 0 to T1, capital T1. T1 to T2 is capital T2. Clear? Here how many clock pulses? 10 power n into T clock. Here X into T clock. This value is this. Now everyone knows that. Right. Which reference signal? Parthiba, I'm coming to that. That reference signal is always given in the instrument. Some value will be there that will mention in the numerical question. No need to worry. That will be taken according to the corresponding display notation only. No need to worry. T1 is fixed irrespective of VM. T1 will be depending on VM only. T1 will be depending on VM only. So therefore, kindly concentrate. Sir, 0 to some value increased. Yes or no? And after that, it is keep on getting reduced. Sir, what is this? During this time, VM is given, and by RC, that is a slope. Negative slope minus V reference is given. RC. Now tell me, whatever this line is there, this line is common for first triangle as well as second triangle or not? Yes or no? Yes, definitely, because this line is common. This magnitude is common. So that's why I'm equating these two magnitudes. If you equate these two magnitudes, the thing will be done. One thing. Second thing. Sir, during this time, integration means, you know that, simply 1 by T1, 0 to T1, Vm dt. Now tell me, what is the meaning of this? Electrical engineers completed with the network theory. Kindly let me know. What is the meaning of this? What is the meaning of this? If you are doing like this, means we are finding which value? You are finding which value? Yes, very nice, very nice, very nice. Area, nothing but average value. Very good, very good, very good. Even though it is miscellaneous topic, yes, you are concentrating. Very nice. Yes, very good. What is this? This meaning is average value. Therefore, what we can say here? Yes, simply the dual slope integrating type ADC gives which value? Average value. Why? Internally, integration is happening over a period of cycle. That is, area we are taking means average. That only I gave you the first one. It gives average value. That's why dual slope integrating ADC always gives average value of the given supply. Average value of the given supply, just like PMMC in electrical instrument and dual slope ADC in digital instruments, average value will be given. This is a proof. Okay, after that, sir, this magnitude, what is that? This is Vm by Rc, time period is T1. So therefore, this magnitude is, what is that? Vm by Rc into T1. Here, this is negative slope and this is T2 time. Yes or no? V reference by Rc into T2. People are asking, sir, keep the negative point here. No, this is getting decreased. No, for that representation purpose, I'm giving negative, but magnitude is V reference only. But direction is reverse. Therefore, I can equate these two. I can equate these two. Yes, Vm by Rc T1 should be equal to V reference by Rc T2. Rc cancel. Vm by T1, Vm into T1, V reference into T2. But, sir, what is T1? 10 power n T clock. What is T2? X into T clock. I'm substituting those at the T1 and T2 place. Sir, Vm T1, V reference T2. 10 power n T clock, X into T clock. Of course, T clock will be same only because clock period will be same. Therefore, Vm into 10 power n, V reference into X. Okay, Vm is unknown. Vm is unknown is equal to V reference by 10 power n. This is always generally constant. According to the given value, this will be taken. And these clock pulses, they will give, these clock pulses are produced so and so if you give so and so input, etc. That is accumulated count, total number of counts in the, what is it? Negative slope line, X. In the examination, these three values will be given. This value you have to determine. This is the overall brief idea I gave you. Of course, total thing I gave you, but what is it? Corresponding written notes I'm giving. Right? This is the procedure to find out. But in the objective paper or in the gate paper, only take this formula and take the question sufficient. But what is V reference? What is 10 power n? What is X? Everything I have given clearly for more and more and more clarity purpose. Clear, guys? Nothing but why I have taken this means dual slope integrating type ADC measures average value. That what to take. And sometimes this question may be there, but this very rare question. Mostly for ECE people, this question is present in the ESC paper generally. But electrical gate and ESC also sometimes chance may be there. Right. Vishnujit, no need to worry. Next one is numerical example. No need to worry. Numerical example. Right, sir. This is right. The DVM using the dual slope technique has a reference voltage of 1000, a fixed time as 10 power 3 counts. What is the voltage indicated if the counter reads 762 on downward slope? What is it? Reference voltage is something given. What is that? 1000. And fixed time as 10 power 3 counts means he is using 3 digit. And how many counts are produced under the downward slope? X is 762. So this is the simple idea given. What is that? Here, reference voltage. V reference is 1000, of course negative, but magnitude I'm taking. And what is that? 10 power 3 counts. What is that? 10 power n is nothing but 10 power 3. And X value is 762. Then he is asking, what is it? VM, or we can say V input. VM or V input. Yes, 762. So therefore, what is it? Vm is equal to, what is the value? Here, V reference by 10 power n, V reference by 10 power n into x. What is V reference? 1000 by 10 power 3 into x is 762. So answer is 762 ohm. It means we have given 762 ohms, unknown value. That's a simple point. Clear? And one more question I'm taking. Answer this. What is the answer? Here also AD, AD, AD. Why Imtiaz Pasha A? Why A? Sangeeta, Urukunda Satish A. Why? Just now given here. Dual slope integrating type ADC. Dual slope integrating type ADC measures average value. So simply, what is it? V of t is equal to 1 plus 1 sine 100 pi t. 1 plus 1 sine 100 pi t. So many ohms. So what is the V average? V average is 1 volt only. Why? Whatever the constant value is, that is what V average. Simple mathematics, network theory, basic point. And but it is a 3.5 device. No, 1 volt will be represented as like this. But few people have given that 1.999. Why? He is not asking on the 2 volts, which is the maximum, this one, but this is the input given. So the answer is this one. Clear? And before continuing the next topic, just I'm announcing the schedule because many people are leaving. I'm announcing the schedule, kindly concentrate. Again, don't get confused. 6:30 to 10 a.m. signals, right? Only for regular batch only means completed students. Don't get confused again. And 5:30 p.m. to 9:30 p.m. right? Synchronous missions. Right? This is for regular batch, morning batch, and evening batch. I think it seems all batches. It seems. Just like yesterday, just like today's schedule only. Evening synchronous mission. That's it. Sangeeta, how do you consider average as? Nagareddy Kavita, synchronous mission by whom, sir? Kindly wait for one day. You will come to know that. Right? Right. Sangeeta, how do you consider average value? Come on here. This is the electrical basic principle, right? V of t is equal to A plus B sine omega t. Find the average value. Taking the integration. What is that? 1 by 2 pi 0 to 2 pi A plus B sine omega t with respect to d omega. If you simplify that, you are going to get A only. Sangeeta, didn't you complete network theory? Definitely. I'll give that. Okay, network theory is not done. No need to worry. If that is done, you'll come to know. But this is a basic point. Don't forget. Means in the simple shortcut we are giving, whatever the value is there without any sine or cosine, etc., constant, that is direct answer 1 volt. In this one, direct answer. So this is the total discussion regarding entire electronic measurements, including miscellaneous topics. We have taken what is it? Starting chapter only, but many a times rare questions are there. Analog voltmeters, then digital, complete discussion, and this is the extra topic. And Q meter, very small chapter. CRO also we have taken voltage deflection, vertical deflection, sensitivity, and all. Okay, now this is especially there in the ESC, but those who are the GATE students, yes, you can. Right. See here, if GATE students are wanted to be online, kindly be online, because this is very important topic for other examinations also, but very small topic. After this, I'll be speaking with you for a few minutes regarding how to prepare and all, etc. People are giving that some tips to prepare and all. I'll give you. No need to worry. Very small thing. Units and dimensions. Right? When I was taking the electrical measurements, I have taken miscellaneous ESC topics also, but except this is universal topic. Pramod Rajendra. Yeah, definitely. Electrical measurements, I only take, no need to worry. Electrical measurements, I only take, no need to worry. Yeah, definitely. After this, I'll be taking. But I'm requesting no one should leave. And that too today, not up to 9 o'clock. Right? Within half an hour, we are going to conclude. That's why no break. So directly we are leaving. Right? See, units and dimensions. First of all, very simple. Very simple. What are the basic parameters? What are the basic parameters available? What are the basic parameters available? Everyone knows that. Generally, here, dimension representation is generally with respect to the square brackets. This is generally represented with square bracket. Everyone knows, but this topic looks like very simple, but very important and very confusing also if you don't concentrate on plus minus. That's why I'm going step by step in detail thing. What is that? Can you concentrate? Right. See, those who are ESC students, for you, this is compulsory topic, right? Old students and new students, is compulsory. But other GATE people, just safe side point of view, for any other examination, it will be useful for your state level examinations and all. That's why I'll be taking at the end of this total thing. Okay, right, sir. What is it? Length. It is denoted with capital L. The moment I start this, people are thinking that, sir, this is very simple. No, I'll be coming to the actual topic, electrical engineering, parameters representation in dimension form. Then you'll come to know. Length. Next one is mass. How do you represent? Simply capital M. Okay. Time. How do you represent? Capital T. Length, mass, time. Okay, these are the basic parameters. After that, these are generally called fundamental parameters, we can say. Fundamental derived parameters I'm taking. So what are those? Simply velocity. What is the velocity formula? Everyone, you need to answer. What is velocity formula? Electrical engineers, tell me. Before answering, kindly be clear. You're an engineer. Kindly be clear and tell me, what is the formula of velocity? Formula I'm asking. Abhishek, I'm asking formula, not unit. Sahil Singh, Dinesh, d by t means what is d? Kundrapu Murali, mass into acceleration. What is this? What is this? Mass into acceleration is force. That's why I told you. That's why I told you. Yeah, many people generally do the mistake. No need to worry. U plus AT. I'm asking formula. I'm asking formula. Okay, right. Area into acceleration. Different formula are giving. Okay, see, many people gave the correct answer, that is displacement by time, but few people gave that distance by time. No, distance by time is speed, not the velocity. For that purpose only I asked. So that's why be clear, displacement by time. Of course, length, this is common. Time, t. So therefore, LT minus 1. Kindly, this is the pronunciation. You need not to say LT power minus 1. No need to say LT minus 1. You can say no problem at all. You can say, what is it? LT minus 1. No need to worry at all. Okay, after that. Now, acceleration. Acceleration. What is it? Acceleration? A is equal to velocity by time. What is velocity? LT minus 1 by time. Therefore, LT minus 2. LT minus 2. Clear? After that, force. Force is equal to mass into acceleration. Mass M. Acceleration is LT minus 2. So therefore, you are getting MLT minus 2. Okay. Now, work done. What is work done? Work done is equal to force into distance. Force into distance. Work done equal to force into distance. What is force? M L T minus 2 into distance is L. So therefore, M L square T minus 2. But don't forget to keep these square braces. Okay, next. What is power? What is power? Power is nothing but rate of doing work. Work done by time. Work done by time. What is work done? M L square T minus 2 by time T. What is that? M L square or 2, no problem. T minus 3. Clear? Right. After that. Sir, what is the energy? Energy is equal to power into time. Power into time. What is power? M L square T minus 3 into T. What is that? M L square T minus 2. Clear? Right. Finally, torque. Now, again, I'm expecting the correct answer. What is torque formula? What is torque formula? Come on. After this, I'm going to start actual topic. Torque formula. Force into distance, force into displacement. Force into distance is work done, right? And only few people give the correct answer. Force into perpendicular distance. Force into perpendicular distance, not the normal distance, a perpendicular. What is force? M L T minus 2. Distance L. Of course, distance is L only, but perpendicular formula is to be clear. Therefore, M L square T minus 2. All these are the things you know generally, basic point of physics, point of view, etc. Okay. Now I'm taking our system. What is that here? I'm taking two systems in the electrical engineering, that is electrostatic system. Electrostatic system means what are the dimensional representations of electrostatic system? What are the dimensional representations of electrostatic system? Generally, basic formula, sir, force between, suppose two charges are there, Q1, right? And then Q2, two charges are there, one is plus, one is minus, for example. Between these two, force of attraction will take place or not? Will take place. What is that force of attraction? What is that force of attraction? Formula, remember? F is equal to F is equal to Q1 Q2 by 4 pi will be the general. I'm writing epsilon r square. 4 pi is constant, no, that is dimensionless, we can say. Simply Q1 Q2 by epsilon r square. I hope everyone knows this. Q1 Q2 by epsilon r square. Okay. So Q1 Q2, if I am assuming same amount of charge for simplicity purpose, Q square epsilon r square. Therefore, Q square is equal to F epsilon r square. Okay. Q is equal to F epsilon r square whole power 1 by 2. Whole power 1 by 2. Clear? Now I'm defining each and every electrical parameter in terms of electrostatic. This is electrostatic parameter. What is this? Permittivity. Permittivity. This is electrostatic parameter representation. Therefore, first one, charge. What is the charge dimension? What is the charge dimension in electrostatic element representation? Means Q is equal to F. What is F? ML T minus 2. Epsilon should be as it is. Why? Our topic itself is representing the parameters in terms of what is that? Electrostatic representation. R square L square whole power 1 by 2. Okay, therefore, what is that? M power 1 by 2. L and L2, L power 3 by 2. Right? And T minus 2, 1 by 2 means T minus 1 epsilon 1 by 2. This is the charge dimension. Right? M only 1 by 2. L 3 by 2. T minus 2 means minus 1 epsilon 1 by 2. This is the dimension of charge. Right? You have to follow this in the examination at any cost. That's why this is the basic representation. You need to follow this. Okay. After this charge, can you get current? After this charge, can you get current? Yes. Current is equal to I is equal to Q into time. Clear? Proceed and tell me. Charge is there with you and time is there with you. Proceed and tell me. Very nice, very nice. Yes, 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 yes. Very nice, very nice. It is not Q into time. It is Q by time. Why I gave, many people are getting confused with small thing. I'm not saying that they don't know. They know, but in the hurry mode, QT, they will proceed. Option will be there definitely. That's why Q by T. Be clear. It is not Q into T. It is Q by T. dQ by dt means Q by T. Okay. Differentiation, no dimension. So therefore, what is charge? M power 1 by 2. L power 3 by 2, T minus 1, epsilon 1 by 2. Just verify every time. m power 1 by 2, L power 3 by 2, T minus 1, epsilon power 1 by 2 by time. So therefore, what will be there? M power 1 by 2 as it is. L power 3 by 2 as it is. Here also people are getting confused. Sir, T will be cancelled. Therefore, epsilon power 1 by 2. In that way, people are giving. These are the silly mistakes. Of course, as a human being, these are generally common. That's why I'm stressing more and more. I'm stressing more and more. Sir, this denominator T going to the numerator side means T minus 2 epsilon 1 by 2. This is the dimension for current. Okay, right. Third one. What is third one? Voltage. Sir, what is the voltage dimension or voltage formula? I think everyone knows that V is equal to work done per charge. V is equal to work done per charge. What is work done? M L square T minus 2 by charge is this. M power 1 by 2, L power 3 by 2, T minus 1, epsilon 1 by 2. We can say or epsilon power 1 by 2 as you wish. Clear? Right? Now, what will be there? M power 1 by 2. Okay. L2 is there, L3 by 2 is there. Don't get confused. 2 minus 3 by 2, 1 by 2. L power 1 by 2. Minus 1 going to numerator side. It will become plus 1 means remaining is minus 1. Epsilon minus 1 by 2. Clear? Right. With all these things, after getting V and I want to get resistance dimension. I want to get resistance dimension, inductance dimension, capacitance dimension. Right. Everyone try this. Resistance dimension, inductance dimension, capacitance. I'm giving this slide. I'm showing this slide. By using this, take your time, just 1 or 2 minutes of time and tell me the answer. Can you tell me? Come on. Right, got it? Resistance dimension, inductance and capacitance. Resistance L minus 1 T epsilon minus 1. Okay. Yeah, that's what I told you. Many people are giving different answers. Right. See, resistance dimension is L minus 1 T epsilon minus 1. Many people give this. Is it correct or wrong? Right. And L inductance, L minus 1 T square epsilon minus 1. These are the answers. If someone is giving some other answers, you might have mistaken with plus or minus 1 by 2 or plus or minus like that, you have mistaken. And capacitance L epsilon. These are the three values. Means our electrical parameters representation in which one? Electrostatic element. That is permittivity representation. Mahesh, kindly check it. These are the final answers. If you are getting these are correct, otherwise you might have mistaken like some denominator to numerator, plus, minus, etc. You might have mistaken. Kindly follow this. Right? Next. Sir, electromagnetic system. Electromagnetic system. Sir, what is electromagnetic system? Same thing. Sir, one is North Pole and one is South Pole is there. Between these two, force of attraction takes place. So what is that force formula? Same thing. F is equal to M1, M2 by, what is it? Mu R square. Their Q1, Q2 means static charges. M1, M2 means pole strength, north pole strength, south pole strength, or both are north or both are south. It may be attraction or repulsive force. Simply M1, M2 by mu R square. For simplification purpose, I'm saying M square by mu R square means same pole strength I'm taking. Therefore, what we can say, M is equal to F mu R square whole power 1 by 2. Whole power 1 by 2. Now, the first topic as usual. What is that? The first one is pole strength. The first one is pole strength. Pole strength. So what is the pole strength? The pole strength is M. What is this? F. What is F? M L T minus 2. Mu should be as it is because of our representation in this form only. And distance between R means distance. So L square whole power 1 by 2. Whole power 1 by 2. Therefore, here, what is that? M power 1 by 2, L power 3 by 2, T power minus 1, mu power 1 by 2. This is M. Clear? Right? Now, after this. Right. Second one. Sir, magnetic field strength. Magnetic field strength. Right? Magnetic field strength, H is, what is the formula? What is the formula? Right? This is force per unit pole strength or force per pole strength, we can say. This is the basic formula. This is new to you. It might be new to you, but general formula. Magnetic field strength formula is force per unit pole strength. So what is force? M L T minus 2. Pole strength already we have taken here. This one, pole strength. So therefore, M power 1 by 2, L power 3 by 2, and T power minus 1, mu power 1 by 2. You are going to get the value, magnetic field strength. Okay. Now from this, I'm going to take third one. What is the third one? That is same magnetic field strength only. Magnetic field strength. Magnetic field strength. The formula, one more formula, Ni by L. One more formula is Ni by L. General formula. Solenoid magnetic field strength, Ni by L. N is anyway number of turns, no dimensions, simply I by L. Therefore, I is equal to H into length. H, you know, this, and length, you know, get this. Are you clear? Right? Simplify this and get this. What is M here? This H value, M by M power 1 by 2 means M power 1 by 2. L power 1 by 3 by 2 is there. L power minus 1 by 2. T minus 2, T minus 1 means T minus 1. It is going upside 1 by 2. So be clear with each and everything. L power 1, L power 3 by 2. So 1 minus 3 by 2. So minus 1 by 2 like that. And get this I value. After getting this I, very simple. Charge Q is equal to I into T. Get this. I is there, multiply with the T. Okay. After that, otherwise let me write here. Into L lower, simply what we can write, M power 1 by 2. L and L power minus 1 by 2 means L power 1 by 2. T minus 1, mu power 1 by 2. Clear? Right. After that, sir, multiply with T, you will get it. And fifth one, voltage V is equal to work done by charge. Work done, you know, charge also, you know. And sixth one, same thing, resistance, right? R is equal to inductance, L is equal to capacitance, C is equal to, right? Everything is there. Kindly tell me R, L, and C, just like earlier discussion. I am keeping this thing, right? Give me the resistance value, inductance value, and capacitance value, dimensions. Come on. In magnetic field strength, mu must be, yeah. I want R, L, and C. Resistance, inductance, and capacitance. Come on. Resistance. L T minus 1 mu. Inductance L mu. Got it? Anyone resistance? Same. L T minus 1 mu. Yes. Allah Navin Sai got it. L T minus 1. Vaishnavi, check it mu. You give and a C value L minus 1 T2 mu minus 1. Just check it this. You are given mu, but it is mu minus 1 actually. Navin Sai. These are the values. Pragati got it, sir. Very good. Got it? Right. This is the total discussion regarding units and dimension. But last one is, I'm making the relation between these two. What is that? You know, resistance, I'm taking just example purpose. Resistance in electrostatic system. What you got in the electrostatic system resistance? L minus 1 T epsilon minus 1. L minus 1 T epsilon minus 1. And what is the resistance we have got? LT minus 1 mu. LT minus 1 mu. Now tell me, can I equate these two or not? Everyone, can I equate these two or not? We can equate. Why? This is resistance. This is also resistance only. Means ohms only. But the system representation is different. But behavior of resistor is always same. So therefore, we can equate. If you're equating like this, what we can write? L minus 1 coming here. L square. T coming over here. T minus 2. And here, epsilon I'm bringing denominator side. Mu I'm bringing this side. So what we can write now? L T minus 1 square. Here 1 by mu epsilon. So what is this? L T minus 1 is equal to 1 by root mu epsilon. So what is this? What is this? LT minus 1? Come on. Yes, very good. Velocity. Okay. Velocity of what? Velocity of dash. Velocity, okay, LT minus 1. But velocity of dash. Very nice. Velocity of light. This is very, very, very important question in the ESC objective paper. Velocity of light. You may be asking, sir, why you have taken only resistance? Why not inductance? You will get same value. Even if you take inductance or capacitance, you will get the same result finally. That's what the point. See, this is the total discussion regarding entire measurements for one batch, electronic measurements for one batch. For those who are not attended the electrical measurements, don't worry, that will be done later. That will be done later, no need to worry. Right. But before concluding the entire session, just let me know a few things. Is this clear, guys? Is everything clear? Can you let me know electronic measurements for a few people? Yeah, Mukul Jagtap. Actually, I wanted to say, but I forgot. Happy Engineers Day to all. Actually, I thought of wishing you, but I forgot. Right. Thank you. Thank you. Right. Clear, guys? Yeah. Sai Charan Reddy. Very good. Very good. Now it's your turn. Now it's your turn. My turn is done. Right? Because I explained everything. Right. Now it's your turn. But yeah, today so many days are there. Yes, International Democracy Day, etc. Okay. Yes, yes, yes. I wish you all happy Engineers Day. Right. Come back. I concentrate. See, very simple logic. Only one thing I wanted to say. Sir, people are asking, sir, how to cover the entire syllabus, how to manage the time, because time is very, very like there's so many excuses people are giving. Very simple point I'll give you. Today, September 15th. Okay, means in September, 15 days time is there. October 31, November 30, December 31, Jan 31 days is there. Okay, you will be getting 138 days. 138 days, right? 138 days is very, 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 very huge number, or we can say very high number also we can say. Very high number also we can say. Clear? Why means simple logic here. See, kindly don't give the excuse like, sir, only 4 months of time is there, only 4.5 months time is there. Yes, okay. But when did you join? Okay, new people, August month you joined. Okay, no problem. For you, I'll come. But other people joined in July or June or May or March, etc. What did you do these many days? If you ask like this, no answer. But other people, those who joined in the August batch or July batch or September batch, etc. No need to worry. From today onwards, I'm saying 138 days is there. 138 into, you should definitely study 10 hours a day. 10 hours a day at any cost. At any cost. This is for whom? College goers, mean those who are pursuing third year or fourth year, etc. But BTech completed and those who are spending full time only on the gate, they have to prepare at least 14 hours. Definitely. Sir, it will be giving 1380. Okay, you may be asking, sir, 10 hours means only for GATE? Yes, I'm saying only for GATE, other than your college work, etc. Only 10 hours. Sir, in this 10 hours, 3-4 hour class will be there? No? Yes, right? Those 3-4 hours class is included in this. That's why always I told you, listen the class carefully. Listen the class carefully. I told you always, listen the class carefully. Right? If you listen the class carefully while the faculty is explaining, the preparation should be done from your side, in that you have to attend the class, but not 100%. But if you attend like that, after the class, the 4 hours class, 1 hour revision is sufficient. Yes, thing will be done. 4 hours class, 1 hour revision. Yeah, let me take 2 hours revision, 6 hours. Rest of the 4 hours for your own preparation. Like that, totally 10 hours at any cost. Okay, half of the time is going for class time, for example, 690. Okay, 690 hours by 10 subjects. Totally, approximately 10 subjects are there. 69 hours other than the class timings. 69 hours preparation, yes, more than enough. more than enough for getting the rank. One thing. And many people's doubt is, sir, I joined in August, I joined in July, I joined in September. Kindly concentrate. The entire history says that those who got the rank below 100, below 20, below 10, or below 200, etc., right? If I take 100 people are there, if I take 100 people are there, 50 will be there. 50 joined in this, right? 50 at March, May, or 1 year preparation, or 9 months, 10 months, 12 months, 18 months preparation will be there. So no need to worry. Those who got the best rank from that, at least 50% of the people who started the preparation from July month, August month, or September month only. So no need to worry. Don't get deviated like if your less time is there, less time is there, no need to worry. One thing. Suppose if you're targeting, your main target is for GATE 2023, for example, those are in the third year, for example, right? Those in second also they might be taking. If you are preparing now, no problem, no tension, right? In this GATE 2020, you write it, you give your best, you give your best, and again 1 more year will be there for you. You prepare well. That's what. But the point here is, sir, I'm in the third year, I'm targeting for GATE 2023, so that I don't prepare well now. No, not like that, right? Whatever your target, 23 or 24 or what it may be, but right now your target is 22 only. In that, you have to prepare. GATE 22 only your target. Keep that point in your mind and prepare. Try to give your best. Try to give your best by feeling like this is my last attempt. In that, you have to feel. Then only actual zeal will be out. Then you prepare. If you are getting the best rank, continue with that. If you are not getting the best rank, if you want to get improvement, yes, try it in the next year. But those who are in the fourth years, means for those who are in the fourth year, for you people, this is ultimately your target. No other alternative. No other alternative at all. You have to prepare more and more and more keenly. You have to take each and every topic. So that's why kindly have the schedule like this. These 15 days of time is there, at least 10 hours, right? Including class hours. Other people 14 plus actually, but I give only 14. Yes, you will be getting almost 75 to 80 hours for one subject. You prepare like that. If you have the schedule like this, automatically you will get confidence. Okay, yes, time is sufficient, etc. Time is sufficient, etc. In that way, right? Sir, I have joined in June. By which month expected? See, I gave the number, no? Manager number kindly regarding the syllabus completion and ask him. You will get better information. Right. ISRO exam, just like GATE preparation, if you prepare for the GATE, just like that only, ISRO will be clear. But people are thinking like, sir, what is the preparation strategy, etc. Only one thing, concept is very, very important for ISRO exam. Fundamentals are very, very, very important. That if you're focusing on fundamentals of every subject, thing will be done. No need to worry. Right. Mukul Jagtap. No problem, no problem. Very nice, very nice. Mukul Jagtap, same strategy you follow, you will get it. No need to worry. People are saying that I failed in 2 times, I failed in GATE 2 times, yeah, 3 times, etc., etc. No need to worry. I'll give you one example, but mechanical student example. This has happened almost 3-4 years back, right? Mechanical student, assume that as 2015 GATE, means 2014 he joined offline class in the Hyderabad Dilshnagar batch. 1 year he has taken the coaching. One student, right, used to sit in the first bench. Mechanical faculty told that used to sit in the first bench, taking each and every notes clearly. And 2015 GATE failed. Again he joined by paying the corresponding fee. Again he joined. 2016 GATE failed. Again he joined, right? Third time our faculty recognize that person. You're coming every year. What happened means he told clearly, sir, I'm a below average candidate. Means the moment I study one thing, I cannot get it. I need to study again and again. That's what my knowledge. So that I did not clear in these 2 years. That's why I'm coming again. Okay. He has, right? He came to the coaching 2017. Observe that the third year coaching. But what he has done, every year he has taken the new notes new notes, and he has written everything clearly. But what we do? Okay, last year coaching is there. Same Ramesh is explaining the measurements. Of course, everything will be same except a few questions. So that, okay, faculty is explaining, just underlining. No, don't do like that. And he has also not done that. Simply he has taken the complete separate notes. He has written everything. Means by writing one time, two time, three times itself is 50 to 60% of subject will be injected into your mind. And then in 2017, he got the success. And he got 6 PSUs. Selection happened in 6 PSUs. That's why you failed one time, two time, no need to worry. If you're really interested in GATE rank, after GATE rank, your wish. MTech or PSU or etc. That your wish. Means if you're really interested, focus. Yes, 6. What is the third time he got the success? 6 PSUs. He got eligibility in fixed 6 PSUs. That is what the simple. That's why once you failed, no problem. Second time you fail, no problem. If you're continuing the preparation, third time you will get the success. Again and again, you will get it. Definitely. If you're having the zeal, you will get it, no problem. Right. Sir, revision classes and examinations, etc. Kindly give the number. No, kindly talk to that person, you will get it. Right. See, only one thing I would like to give you one more example also. That is my personal example. Sir, will ESC people have separate sessions, sir, after this measurement is over for ESC also? No, I covered everything, right? Measurements for both GATE and ESC covered, objective point of view. No need to have separate. If the subject is separate, then that will be, but measurement is common. No, I gave everything, no need to worry. Right now, one more simple example I'm giving. Right, Bhavana Rapeti. So please say opportunities in electrical sector. Right. See, opportunities will be through the GATE exam I'm giving here. First, MTech. That you know. Second, PSUs. These PSUs are 40 number. For electrical people, 40 PSUs are there. And you can go to management courses also, MBA. You can go with the GATE rank, and you can do PhD, and you can become research scientist also. These many opportunities are there for electrical people. Other than this, what is it? State level, right? GENCO will be there, Transco will be there, and DISCOMs will be there. Other than that, SSC, JE Electrical, and Indian Air Force on the BTech qualification. RRB also there. And every state, right? Suppose I'm talking about, for example, Andhra Pradesh, APPSC, right? Telangana, TSPSC, like that. Tamil Nadu, TNSPSC, like that. Every state has, what is that? State Service Commissions, right? You are eligible. These many number of opportunities are there for electrical people. Other than this, ESC also there. ESC. These many opportunities are there. Kindly don't get degraded like, yes, Dinesh Rampur, MPSC, yes, Maharashtra means MPSC, like that. Yes, you are eligible. Electrical students are eligible. But whatever the thing you are hearing, from your seniors or etc., electrical branch is waste. No, electrical branch is the best, but the people don't understand. That's why the people are not. Problem is not with the branch. Problem is with the people who are not taking the electrical branch. And to have the confidence, I'm giving one more example. My sister's daughter, just 3 years back, she has completed 10th class. After 10th class, I made her to come in the polytechnic way, right? And in the polytechnic entrance, he got EC branch, electronics and communication, in the counseling, web counseling, it's a counseling, EC branch. But I cancelled that seat. We have taken the management seat in the electrical branch. Generally, people feel like EC has more opportunities compared to electrical. No, no, electrical itself is having more opportunities. But you may be thinking, sir, if you are saying like that, but my seniors are roaming on the road, means they have not utilized the resources properly. They have not utilized the resources properly. That's why they're still facing the problem. But do you feel like from your seniors classroom, 60 members were there? Do you feel like all 60 out of 60 are roaming on the road? No, few people got settled well, but we don't see them because they are busy in their life. Who will be coming across us means those who are roaming on the road, those who are wasting the time. We will see them and we will look at them. Okay, my senior did not get the job because electrical branch. No, because of his problem, because of her problem. I'm openly saying, and I'm giving my example also. Right, my sister, my niece, I cancelled this EC branch, electrical. She has completed this year only. Now she is joining BTech electrical. That's what electrical. If you are utilizing the resources properly, the beautiful branch is electrical branch. But many people don't know. That's what the problem. Yes, Apratim Pandey, UPPSC, Uttar Pradesh, right? Right. Mukul Jatta, that's what the realization. Very good, very good, very good. Yes, software craze is on one peak. Yes, software craze is there. Software craze is there, but that is not permanent according to my wish. Sorry, according to my opinion. Right? So few students are there. Those who are working in the software company since 4 or 5 years, they are working in Bangalore, but still they are in the dilemma of going to US for pursuing MS and etc. etc. They are thinking something else. Right. Shreyas Sasi, don't think like I'm an average student. No, if you're feeling that everyone is like you only, right? No one is not what is a God gifted person. No, only 1-2% will 1% is maximum God gifted like that. But generally, every student is like you only. All students are average or above average only. Don't by looking at few people, don't think in other way. Only few people will be there, just they are seeing like this, they get it. That is very rare cases, so you don't get confused, you don't get degraded. But those who are very talented don't get a negative point from this. Right, Vikrant Bandela. Yes, I'm also polytechnic background only. Right, actually syllabus for almost all examinations in all over India is almost same. 80 to 85% of syllabus is same here. At least 80% of syllabus is same. But if the examinations are different, so that's why I suggest everyone, if you prepare for the gate seriously, strictly, sincerely, you can write any examination all over India. Not only writing, you can get selection in that job also. You can get selection in that job also. No need to worry. Sai Charan Reddy, that is correct, but I can't say openly that. But that is true. That is true. Right. How much gate score is to be required to get into the PSU? I mean, that depends on different company. First, you focus on the gate to get single digit rank. If not, worst case, double digit rank. Focus that, then you will get it. Right? Prajit Tyagi, below 100, how many marks? I mean, that depends on the first rank generally. That's why always target for 80 plus marks and a target for below 10, single digit rank. Yes, go ahead. Go ahead. Right. Priyavat Raj, how to go clearly? What we do, okay, I know that. See the question we tried. getting stuck up, again trying getting no. First see the question clearly, go through each and every step, and by seeing, by looking, you write that on one paper in the rough way, not neat way. Then you go for other question, then you can understand. That's why read the question carefully. Whatever the questions are solved by the faculty in the class, those questions also read them carefully. I attended the class, so that I will not like that. Then you can improve your speed, no problem. Like transducers included in PSUs and ESC, that will be taken separately, no need to worry. That is only there in ESC. Yeah, Shruti, yes. PSP will compulsory. Lecture notes and questions solved by the faculty, and then go for the previous questions, right? Gate questions, previous questions should be after completion of the lecture notes. If you properly follow the lecture notes, practice questions will be there, normal questions will be there, previous gate will be there, previous ESC also will be there. Vaishnavi Suryavamshi. Sir, our network is, yeah, it will be done. See, simple logic here. Only one thing, whatever the subjects completed in the academy, right, is not important. Whatever the subjects are not completed by the academy right now, not important. What is important? Whatever the subjects completed in the academy are done by you completely or not. That is what important, right? I completed myself, my thing is done, but your turn is, that's why, sir, measurement is complete, not completed. By me it is completed, but by you it is pending. When you should say measurement is completed means when you completed, measurement is completed. Power system completed by you, then only you can say power system come. That's why those subjects are not done yet, no need to worry. What are the subjects completed in the academy, those are completed by you or not. That is what the very, very important. Right. In the GATE exam, Gurudatta Behera, speed and accuracy, both are important. Both are important. Yeah, test series is necessary, definitely. Examination, if you write as many as examinations you attend, you can get more and more practice. That much practice will be there. Right. What should be the strategy in January month? Generally, January month, complete revision should be there. Means by the December month only, you try to complete the syllabus. January month, 31 days into 14 hours for every people, 420 hours, 420 by 10, 42 hours for each and every subject. One subject will be less, 30 hours is sufficient. One subject is lengthy, 30 plus 42 plus 12, like that. You balance that. In January month, complete revision should be there. So this is the total discussion regarding the entire electronic measurement, and for a few people, complete measurement, gate and ESC, everything is taken. Gate and ESC, everything is taken. Clear? Right. Tomorrow schedule also I have given. No need to worry. I gave my number. My number is with you. You can talk to me anytime. You can talk to me anytime. If any doubt is there, if any time you are getting demotivated, simply you call this number. If I'm not attending your call, just drop a message. I'll call you back and I'll speak with you. I'll motivate you. No need to worry. And for any doubt, you can send this. You can send, no problem. Right? And a few people are asking that, so I don't have WhatsApp. I can't send it. I have only Insta. So can you have Insta? Yes, I'm giving my Insta. Because few people are not using WhatsApp, it seems. Few people are asking Telegram, my number. If you type a Telegram, you will be there, you will be getting. And some people are saying, asking that, so I will send the doubt through Insta. Yes, this is what my thing. You can contact through any platform. Right. Mukul Jagtap, actually due to some other things, I was busy. I'll send you, no problem. I'll send you. Bhavana, thank you. Be in touch with me for the doubts clarification. Anytime you can send it, right? If not immediately, within 1 day or right, based on the time slot, I'll answer. No need to worry. Yeah, Vikrant, kindly, I can't give that clarity. Kindly talk to the person. You will get that. Right? You can contact with me. Anything as you wish. Right? Shall I conclude the session? Not Mukul Jeta. Kindly repost it. It will come to the top. No, I'll send you. Right. Thank you, everyone. I'm concluding the session. Thank you, everyone. All the best, guys. Prepare well. Don't waste the time. You formally you practice more and more. You practice more and more. Right. If you want to give what about my teaching, etc., you can message me. Thank you. But Saukya, we really miss your lectures. I posted this even at the end of it. Thank you so much. Thank you so much. Right, my session is done, but I'll be in touch with you all. Right, thank you. Right, actually, free time means I'm not that much busy, but based on the schedule, I may be busy sometimes. You drop a text message. I'll let you know. No problem. Right, Vikrant Bandela. Yes, we will meet in electrical measurements. Right. Thank you. All the best. See how to calculate inductance and capacitance dimensions. L equal to formula is V equal to L dV by dt. I equal to C dV by dt. You will get that by using that formula. Right, Madhuchandra, regarding schedule related examination, etc., you call them. Right, thank you. All the best.